All right, let's try in 16.5, number 5, we want to express the equation of a cone in spherical. Please note, spherical is probably the what kind of tool for this? Wrong tool. That's, yeah, not actually a bad point. Okay, so in order to change something to spherical, I think I first have to what?
Change it to polar.
Don't do that.
Put it in
That could be
cylindrical.
You make that x squared plus y squared r, and then that'd be, or r squared, and it turns into r squared.
Yeah, so this in spherical is maybe a pain in the butt. This in cylindrical is pretty chill, right? This is just z is r. Check, done. But that's cylindrical. So to convert it to spherical, I think you need to
I see it now.
Is it
get the conversion factors for spherical, right?
r squared?
Is z like r cosine of phi or something like that? Or
Oh, I think we should probably figure that out since maybe we didn't the other day, right? Okay, so let me sketch some of these guys. These guys. The usual x, y, and z, right? And so I have a point out maybe here, which I'm going to call x, comma, y, comma, z. Right? It's like back some amount to like there maybe, and then we go out in the y a little ways. Oops, and I put it in the wrong spot. Right? You guys all good with this? Okay, so I need to figure this thing out in terms of, like, I'm looking at this guy and I'm thinking rho, theta, phi. So I need to figure out some conversion factors, right? Is all with me on that? Okay, so let's see. So there's a theta there. There's a phi here. And which one of these two is rho? Yeah, the long one is rho, right? The one that actually goes from the origin up to the point. You guys all with that? So one thing I could immediately observe is like rho squared is x squared plus y squared plus z squared, right? Okay, cool. That's a conversion. All right. How can I get the others? What did you guys say z was? You hypothesized something, right?
I hypothesized the I said b. I said r cosine phi, but I'm assuming it's the p low. It always looks like a p to me, but rho. Thank you. I guess it would be rho cosine phi, not r.
You guys kind of with that? Let's double check that. So that's pulling this triangle out of there, right? Where this is the angle phi and this is rho. And z is, oh, maybe it's pulling this triangle out of there, right?
Yeah.
You guys with me on that?
Oh.
So z is in fact that adjacent side. You guys see that?
Wait.
That's a z sideways.
Oh.
Wait.
Because I'm looking at that this way, right?
Shouldn't it be this short? Oh wait, no, never mind. Sorry.
Yeah, keep in mind my picture is not actually to scale, right? I'm just kind of pulling this triangle up, thinking about it. Okay, so seems like I figured out that z is rho cosine phi. If all down with that?
The x we'd have to do 2 cosines, wouldn't we?
Yeah, and for the x's we have to do something a little more complicated. So what's the other side in this thing?
That would be
Cosine.
r
Root x squared plus
Yeah, it's root x squared y squared, right? That's the usual r from polar. But it's also rho rho sine phi, right? This is the opposite side in that picture. That's this side here. You guys all with me on that? No?
Where are you getting that?
So I'm just looking at this triangle here. This triangle has an adjacent side that's z tall, right? And then it's got an opposite side that I don't really know. It is the square root of x squared plus y squared. But it's also just the opposite side in this triangle. So I might write it as rho sine phi. Basically what I'm noting is that the r from cylindrical is rho sine phi.
Oh.
Right?
Yeah.
And then I know some conversion factors, right? I know that like x is r cosine theta, and y is r sine theta in cylindrical land, right?
Ours is a rho sine theta.
But r is rho sine phi. You guys cool with this? So I found out x is rho cos phi. Sorry, z is rho cos phi. X is going to be rho
Sine phi.
sine phi cosine theta. You guys with that? And y is rho sine phi sine theta.
Okay, you have to put all of that into your original.
Uh-huh. So we need to cram all that into our original cone thing, right? You guys with me? So I think what I got is z is, oh wait, z though is rho cos phi,
Sine phi.
right? And this other thing is the square root of that whole mess squared, right?
Mm-hmm.
Would it be possible to just treat that like r squared and then put
Yes.
rho sine phi squared?
Yeah, absolutely.
Rho sine phi.
That's rho sine phi. Which you'll get if you put all that shit in and simplify a little bit. You'll get a sine squared theta plus a cosine squared theta. You can drop that theta. You'll get this. Should be noted that there are some problems with absolute values here, right?
Yeah.
You guys all with me on that? Like I took the square root of something squared here and nixed it. So I am kind of worried about my signage, but phi, where's phi live?
It's on the z. It's off.
Yeah, it's off the z, right?
And this is a positive cone.
And this is a positive cone, so my whatever phi is going to be between 0 and 90 degrees. And both of these things are positive between 0 and 90 degrees. You guys cool with that? Okay, what else can you drop here?
The rows, sorry.
Yeah, you can really drop the rows, right? So you got cosine phi is sine phi. As long as rho is not 0, right? You guys see that? But when rho is 0, it doesn't really matter what the frickin' angle is because it's 0 long, right? You're talking about the origin either way. Cool with that?
Where did that rho cosine phi equals rho sine phi come from?
That came from me thinking z is r.
Oh.
Right.
Yeah.
You guys cool with that? Okay, so when is cosine of an angle equal to the sine of the angle?
Pi over 4 or negative 3 pi over 4.
So why not negative 3 pi over 4? Yeah, because phi is the angle off the z-axis. It lives between 0 and pi, right?
Yeah.
You guys cool with that? Check done. Remember when we said spherical was the wrong choice? Kinda.
Then.
Spherical's only the wrong choice in that finding out this equation is hard. Unless you've played this game before, in which case you know cones are always just constant angles. Circular cones are constant angles.
I think you could kind of figure it out without even writing down the equations, by just thinking about the shape of the cone, and like you were standing on that chair with the ruler, and thinking how would you have to go to get that shape of the cone.
Perfect. You guys all see that?
Theta is free and rho is also free.
Yeah.
As long as you drop down 45 degrees and spin yourself around, you're gonna get that shape.
You guys see that? So, yeah, the geometry here is good intuition. Because in that tangle of, like, simplifying trig functions, right? I know that I ought to get something pretty simple just about the angle.
Why is Z the long part instead of the short part of the triangle?
Oh, just because I drew the triangle wrong when I pulled it out.
Because whenever I turn it around, Z, the distance to Z is the short line.
Yeah, but it doesn't matter at all, right? This is just a,
Oh, okay, never mind.
right? It's literally, this is,
Yeah, I forgot the phi was over there, and I was actually going by, the shape of this triangle. So, yeah, sorry.
cool. Everybody good? Check, done?
Yeah.
Okay. Cones are consummation.